All right, today we are diving into something that sounds like it's straight out of science fiction, but it is very, very real. We're talking about teaching your own body, your own immune system, to hunt down and fight your specific cancer. This is the incredible cutting edge science of personalized cancer vaccines. So let's get right into it. First things first, we kind of have to rewire our brains about what a vaccine is even for. For centuries, they've been our shield against diseases. But now, well, scientists are sharpening them into a sword for a completely new kind of fight. And this lays out the difference perfectly. On one side, you've got your standard preventative vaccines. Think of the HPV vaccine. It protects you from a virus that might cause cancer down the line. That's the shield. But on the other side, and this is what we're talking about today, are therapeutic vaccines. They aren't about prevention. They're designed to treat a cancer that's already there by turning your immune system into a highly targeted weapon. So here's the bottom line. The goal is to take the exact same logic we use for fighting something like the flu and apply it to fighting cancer. You show the immune system a very specific target, you let it learn what the enemy looks like, and then you just let it loose to hunt and destroy. Okay, but that brings up a really big question, right? If your immune system is going to go on the attack, how does it know which cells are the bad guys and which are your healthy cells? It needs a target. It needs a unique fingerprint that screams cancer. So one potential target is something called a tumor-associated antigen, or TAA. Basically, these are proteins that cancer cells just go crazy producing, way more than normal. But here's the problem. Healthy cells can have them too, just in smaller amounts. So targeting TAAs is kind of like telling your immune system to attack anyone wearing a red hat. Yeah, you might get the bad guys, but you're also going to cause a lot of collateral damage to innocent healthy cells. Not great. And this is where the real game changer comes in. Neoantigens. You see, cancer is all about mutations. Think of them as typos in a cell's DNA instruction book. Well, sometimes these typos create instructions for brand new proteins that the body has literally never seen before. These are neoantigens, and because they only exist on cancer cells, they are a perfect exclusive target. And the reason why they're so perfect is so important. Because these neoantigens are completely foreign, the immune system looks at them and sees an invader, just like it would a virus. It says, whoa, I have no idea what that is. It doesn't belong here. And it launches a way stronger, more focused attack with much less risk to your healthy tissue. So get this, if every cancer has its own unique set of neoantigens, that means the treatment has to be completely unique too. Creating one of these vaccines is this incredibly complex, futuristic journey that is tailored from scratch for every single patient. Let me walk you through it. It all starts with a biopsy. They take a sample of the tumor and a sample of healthy cells. Then, scientists sequence the DNA from both to find all those unique typos that only exist in the cancer. Next comes the really cool part. They use powerful AI and bioinformatics to sift through all those mutations and predict which ones are going to make the best possible targets for the immune system. After they've selected the top candidates, they actually manufacture a completely bespoke vaccine just for that one person. The whole process can take a few weeks, but it's the definition of personalized medicine. Okay, so once you know what the targets are, you still have to get that message to the immune system. And this is where scientists have a whole toolkit of different delivery methods or platforms they can use. One platform we're all pretty familiar with now is mRNA. It works just like the COVID vaccines. They inject a little piece of messenger RNA that has the instructions for the tumor's neoantigens. Your own cells read those instructions, start producing these foreign cancer proteins, and basically hold them up for the immune system to see, saying, hey, this is the enemy, go get it. Then there's a more direct approach, a peptide vaccine. Here, instead of injecting the instructions, scientists just make the neoantigen proteins themselves in a lab. Then, they inject those proteins directly into you, usually with something called an adjuvant, which is basically a substance that acts like a big flashing red light to get the immune system's attention and say, hey, pay attention to this. And then there's this strategy, which is just incredible. It's like training the immune system's own generals. There are these master coordinator cells called dendritic cells. Doctors can actually take these cells out of a patient's body, expose them to the neoantigens in a lab to train them, and then put those supercharged cells back into the patient, where they sound the alarm and lead the attack. Now, this all sounds amazing, and it absolutely is. But we have to be real here. This isn't some magic bullet, not yet. The road ahead is, as the researchers themselves say, long and winding. There are still some pretty big hurdles to get over. So what's the holdup?
right? Why can't we just give this to every single cancer patient tomorrow?
Well, there are a few major challenges. First, tumors are smart. They build this kind of defensive fortress around themselves. It's called an immunosuppressive microenvironment, and it basically shuts down any immune cells that try to attack. Second, cancer is a master of disguise. If it feels like it's under attack, it can actually evolve and just stop making the neoantigens the vaccine is targeting, essentially turning invisible. And of course, there are the practical problems. Making a custom vaccine for every person is slow, it's complicated, and it is very, very expensive. Plus, some tumors just don't have enough good targets to begin with.
And that quote really nails it. The idea is incredibly powerful, but getting past these roadblocks is going to take a ton of hard work and new ideas from the entire scientific community. But you know what? There's a huge amount of optimism. The key to unlocking the true power of these vaccines probably isn't using them by themselves, but making them part of a team.
The strategy is to use the vaccine as a primer. It gets the immune army all revved up and points it in the right direction. Then you can bring in other drugs to help break down the tumor's defenses, which makes those vaccine-trained immune cells way more effective when they arrive. This chart gives you a sense of that synergy. A vaccine by itself might help a bit. Same with another kind of immunotherapy called a checkpoint inhibitor. That's a drug that takes the natural brakes off your immune cells. But look what happens when you put them together. The vaccine trains the T cells to find the target, and the checkpoint inhibitor releases the brakes so they can attack at full throttle. The results can be so much better than either one could do on its own.
And listen, this isn't just a theory. We have amazing data from a real clinical trial for patients with high-risk melanoma. The people who got a personalized mRNA vaccine plus a checkpoint inhibitor had a 44% lower risk of their cancer coming back or of dying compared to people who only got the checkpoint inhibitor. That is a huge deal. That's a life-changing number.
Which really leaves us with this incredible final thought. We're moving into a new era of medicine, away from one-size-fits-all approaches. With neoantigen vaccines, we're not just treating a disease we call cancer, we're creating a unique battle plan for a patient's individual tumor. So could the future of cancer therapy be a treatment that is truly and as profoundly unique as you are?